Okay, let's continue. Next important non-metallic element is carbon. Although it constitutes only about 0.09% by mass of Earth's crust, carbon is the essential element of living matter. It's found free in the form of diamond and graphite, and it's also a component of natural gas, petroleum, and coal. Coal is a natural dark brown to black solid used as a fueler. It's formed from fossilized plants and consists of amorphous carbon with various organic and some inorganic compounds. Carbon combines with oxygen to form carbon dioxide in the atmosphere and occurs as carbonate in limestone and chalk. Diamond and graphite are allotropes of carbon. In this picture, you can see the phase diagram of carbon. Although graphite is the stable form of carbon at 1 atmosphere and 25 degree in normal condition. Owners of diamond jewelry needn't be alarmed, for the rate of the spontaneous process is extremely slow. Millions of years may pass before a diamond turns to graphite. Synthetic diamond can be prepared from graphite by applying very high pressure and temperatures. In this figure, you can see synthetic diamond and its starting material graphite. Synthetic diamonds generally lack the optical properties of natural diamonds. They are useful, however, as abrasive and cutting concrete in many other hand substances, including metals and alloys. Carbon has the unique ability to form long chains consisting of more than 50 carbon atoms and stable rings with 5 or 6 members. This phenomenon is called catenation, the linking of other atoms. Carbon's versatility is responsible for the millions of organic compounds made up of carbon and hydrogen, other elements such as oxygen, nitrogen, and halogens found on Earth. Let's study this one is a synthetic diamond and graphite. Let's study compounds of carbon. Let's start from carbides and cyanides. Carbon combines with metals to form ionic compounds called carbides, such as, for example, calcium carbide and beryllium carbide. Those ions are strong Bronsted bases to react with water as follows with equations. For example, this reaction of carbon anion from calcium carbide is from beryllium carbide. You can see the oxidation state of calcium carbide. Carbon has a -2 and -4 in beryllium carbide. They can react with water, and the product of this reaction will be acetylene and methane. Carbon also forms a covalent compound with silicon. Silicon carbide is called carborundum and is prepared follow this equation. silicon dioxide or sand, and with reaction with carbon give us silicon carbide and carbon monoxide. Carborundum is also formed by heating silicon with carbon at 1500 Celsius degree. Carborundum is almost as hard as diamond, and it has the diamond structure. Each carbon atom is tetrahedrally bonded to form four silicon atoms, and vice versa. It's used mainly for cutting, grinding, and polishing metals and glasses. Another important class of carbon compounds are cyanides. Contain an ionic group Cn is a triple bond between carbon and nitrogen. Cyanide ions are extremely toxic because they bind almost irreversibly with iron-3 ion in cytochrome oxidase, a key enzyme in metabolic processes. Hydrogen cyanide, which has the aroma of bitter almonds, is even more dangerous because of its volatility. Its boiling point is 26. A few tenths of 1% by volume of hydrocyanic acid in air can cause death within minutes. Hydrogen cyanide can be prepared by treating sodium cyanide or potassium cyanide with acid, for example, hydrochloric acid. Because HCN is a very weak acid, in solution is called hydrocyanic acid. Most of the HCN produced in this reaction is in the non-ionizated form or molecular form. Leaves the solution as a hydrogen cyanide gas. For this reaction, acids should never be mixed with metal cyanides in the laboratory without proper ventilation. Cyanide ions are used to extract gold and silver, although these metals are usually found in the uncombined state in nature. In other metals ores, they may be present in relatively small concentration and are more difficult to extract. In typical process, the crushed ore is treated with an aqueous cyanide solution in the presence of air to dissolve the gold by forming the soluble complex of gold. This one is soluble complex of gold with cyanide anion, and then this complex you can separate it from the other insoluble materials by filtration, and you can treat it with electropositive metal, for example zinc, to recover gold. Another important compounds of carbon is carbon oxides. Of the several oxides of carbon, the most important are carbon monoxide and carbon dioxide. Carbon monoxide is a colorless, odorless gas formed by incomplete combustion of carbon and carbon-containing compounds. This one. Carbon monoxide is used in metallurgical processes for extracting nickel in organic synthesis and in the production of hydrocarbon fuels with hydrogen. Industrially is prepared by passing steam over heated coke. We already talked about it. Carbon monoxide burns readily in oxygen to form carbon dioxide. This one. Carbon monoxide is not acidic oxide, and it's only slightly soluble in water. Carbon dioxide is a colorless and odorless gas. Unlike carbon monoxide, carbon dioxide is non-toxic. It is acidic oxide. Carbon dioxide is used in beverages, in fire extinguishers, and in the manufacture of baking soda and soda ash. So carbon hydrocarbonate and sodium hydrocarbonate and sodium carbonate. Solid carbon dioxide, called dry ice, is used as a refrigerant. Coal, which is also known as petroleum and natural gas, mostly methane, are collectively called fossil fuels because they are the end results of decomposition of plants and animals over tens or hundreds of million years. Oil and natural gas are cleaner burning and more efficient fuels than coal. So they are preferred for most purposes. However, supplies of oil and natural gas are being depleted at an alarming rate, and research is underway to make coal a more versatile source of energy. Coal consists of many high molar mass carbon compounds that also contain oxygen, hydrogen, and small amounts of nitrogen and sulfur. Coal constitutes about 90% of the world's fossil fuel reserves. For centuries, coal has been used as a fuel both in homes and industry. However, underground coal mining is expensive and dangerous, and strip mining, that is mining in open pit after removal of the overloading earth and rock, is extremely harmful to the environment. Another problem, this one associated with the burning of coal, is the formation of sulfur dioxide from the sulfur-containing compounds. This process leads to the formation of acid rain. One of the most promising methods for making coal are a more efficient and clear fuel involves the conversion of coal to a gaseous form called syngas, for synthetic gas. This process is called gasification. In the presence of very hot steam and air, coal decomposes and reacts according to the following simple scheme. You can see here the carbon react with water, and the carbon monoxide and hydrogen gas was formed. We already talked about this reaction. Hydrogen also can react with carbon and give us methane. The main component of syngas is methane. In addition, the first reaction yields hydrogen and carbon monoxide gases and other useful byproducts. Under suitable condition, carbon monoxide and hydrogen gas combine to form methanol. Methanol has many uses, for example, as a solvent and a starting material for the plastics. Syngas is easier than coal to store and transport. That small is not a major source of air pollution because sulfur is removed in gasification processes.